All right, let's get into this. We're about to look at an idea that honestly sounds like it was pulled straight from science fiction, but it's actually grounded in some very real, very fascinating neuroscience. So get ready to meet Robek, the biodigital twin.
But before we get there, we have to start with a question that I think is on the mind of pretty much every parent today. I mean, we're all surrounded by screens, right? Tablets, phones, they're just part of life. But when we hand them to our kids, are we really giving them a leg up on the future? Or are we maybe, accidentally, holding them back?
And that really brings us to the core issue here, what we're calling the screen dilemma. See, the problem isn't just what our kids are watching, it's the flat, 2D nature of the screen itself. And that little difference turns out to be a much bigger deal than you might think. So, take a look at this. It shows what's actually happening inside the brain. When a child is just looking at a 2D screen, it's really only lighting up one main area, the visual cortex. But, true learning is about so much more than just seeing. The parts of the brain that handle movement and sensory feedback, the parts that get built up through touching and doing, they stay pretty quiet. The model calls this incomplete brain wiring. Okay, so if screens are giving us an incomplete picture, what does complete learning actually look like? To answer that, we've got to dive into a little bit of neuroscience. It all starts with these amazing things called mirror neurons. Seriously, these are like the brain's social superpower. When you watch somebody else kick a ball, a little part of your brain fires up as if you're the one kicking it. It's the reason you might yawn when you see someone else yawn. This is the foundation of learning by watching, of empathy, of imitation. It's basically our built-in monkey see, monkey do system. But just seeing something isn't enough to master it, right? To really lock in a skill, you need practice. And that's where the second big idea comes in, Hebbian learning. The core principle is so simple and powerful. Neurons that fire together, wire together. Just think about learning to ride a bike. The first few times, you're wobbly, it feels impossible. But with every try, the connections in your brain for balancing and pedaling get stronger, faster, thicker. Practice literally builds the skill into your brain.
And here you can see how those two ideas are the perfect 1-2 punch for learning. Mirror neurons let us watch and understand an action, and then Hebbian learning lets us lock in that action through repetition. Observation plus practice. That's it. That is the fundamental loop of how humans have learned for thousands of years. So the real challenge is, how do we create technology that actually uses this natural process instead of ignoring it?
And that question, well, it brings us to the solution being proposed here. It's time to think beyond the flat screen. It's time to meet your digital twin.
And this is Robek. Now, this isn't just another gadget. It's designed to be a biodigital education twin. The whole concept is pretty wild. It's a technological partner that a child gets at birth, and it's designed to grow, learn, and evolve right alongside them, creating this totally unique developmental bond.
This slide basically shows you the engine that makes the whole thing work. It's a constant learning loop. The child, the biotwin, learns from the robot. But here's the key. The robot or techno-twin is also constantly learning from and adapting to the child. And what's the target? An incredible 12,000 hours of optimized, back-and-forth interaction over the first 12 years of life. So what does this actually look like day to day? Let's take a look at the Robek journey and see how it literally grows up with its human partner. First off, why a physical robot at all? Why not just a smarter app? Well, this chart spells it out. Learning from a screen alone is only partially effective. But look at that bar on the right. When you bring in a physical robot that engages hearing and movement, you get what's called multimodal integration. You're learning with your eyes, your ears, and your body, your whole brain, and that just skyrockets the learning speed. And the journey itself is incredible. It actually starts before birth, with an acoustic belt that introduces the baby to sounds and rhythms. Then for newborn, it's a very simple, gentle form. As the baby starts to move, Robek becomes a crawler to play with. Then it evolves into a more humanoid shape to help with complex movements and social cues. And finally, it becomes a peer, a mentor, helping with really advanced problem solving. It literally transforms at each stage of a child's development. So, you have to wonder, after 12 years of this kind of deep biodigital partnership, what's the result? What kind of person emerges? This is where the whole vision gets really, really ambitious. We're not just talking about smarter kids anymore. We're talking about a potential change in what it means to be human. The ultimate goal here, the whole point, is to develop what the creators are calling a sixth sense.
Just try to imagine a generation of people who grow up with a completely native digital intuition, an effortless, seamless ability to navigate the physical and digital worlds as if they were one single integrated reality.
And these aren't just vague hopes. The predicted outcomes are incredibly specific. They expect language to be accelerated, with first words coming up to 2 months earlier. Frankly, staggering 200% increase in digital aptitude. And maybe the most important of all, the development of a hybrid intelligence, that deep, intuitive grasp of our increasingly complex world.
It all boils down to this one very powerful equation. A bio baby plus Robek equals the future's Homo Digitalis.
Which, of course, leaves us with one huge final question to think about. If a technology like this really works, if it rewires our development from the very beginning, are we just building a better learning tool, or are we actually witnessing the dawn of a new kind of human?